Hello, this is a single flyer spinning wheel. The flyer mechanism is actually this part at the top. Now, the flyer was invented, as best we know, in the 15th century. There is an early drawing from about 1480 that shows a single flyer wheel. As such, the flyer can be considered a child of the Renaissance. In fact, it was one of the leading lights of the Renaissance, Leonardo da Vinci himself, who helped devise the mathematical ratios that made the flyer possible. Now, what the flyer does is that in one elegant process, it combines what had been two separate steps, which we've been following through the entire series of the history of spinning. On the one hand, there is a twisting of the fibers into a thread, and the second consecutive step is wrapping and storing that thread. What the flyer does is it combines both into a continual process. What we're going to do is we're going to take a look just at the flyer and see how it works. This is the flyer mechanism. It has a metal shaft. It has a U-shaped wooden piece that is the actual flyer, complete with metal hooks on each arm. There is a bobbin in the middle, and at the far end is a wooden whirl that actually screws on and keeps the bobbin from falling off. Now, the metal shaft tapers at one end and flares out at the opposite end. Where it flares out, there is a hollow tube, and the thread goes through the hollow tube, up over the metal hooks, and then you can actually use these hooks to fill the bobbin evenly from one end to the other. Now, this acts as a kind of manual fishing reel. However, on a fishing reel, the line is loaded automatically from one end to the other to fill it evenly. On the bobbin and the flyer mechanism, you have to manually lift the thread off each hook and move it to an adjacent hook in order to fill the bobbin evenly from one end to the other. Now, the bobbin is drilled out. It has a wooden core that's hollow. It actually slips and fits over the metal shaft. As I said, the wooden whirl screws onto the shaft and keeps the bobbin from slipping off. Remember, I talked about Leonardo da Vinci helping with the mathematical ratios that make the bobbin work. The math part comes in at the end with the whirls and the bobbin. You'll notice there are two grooves on the whirl, and I'm going to reach down for one of my props here. I want you to be able to see the difference in diameter between the two grooves on the whirl. One groove is slightly larger than the other. The drive band goes into either groove to turn the flyer around. Think of these grooves actually as being a kind of wheel. Now, the larger the wheel, the larger the diameter of a wheel, the slower it turns around. The narrower the diameter, the smaller the wheel, the faster it turns around. And that's the basis for creating the flyer mechanism. Now, the bobbin itself also has a groove on it. And this groove is actually narrower, smaller than either of the grooves on the whirl. Now again, the smaller the diameter of the wheel or the groove, the faster it will spin around. And this is the key to how the flyer mechanism works. When the drive band is adjusted into the groove of the bobbin and starts to turn around, it spins the bobbin. And because the groove in the bobbin is smaller than the grooves in the whirl, the bobbin turns faster than the flyer itself. Because the bobbin is spinning faster, it actually draws the thread onto itself and stores it. So we have the bobbin turning at one speed, a very fast speed, and the flyer mechanism turning at a slightly slower rate of speed. Both are turning, both are revolving, both are going around like this. But the bobbin is turning faster than the flyer. And for that reason, it pulls the thread through the hollow tube up over the metal hooks and wraps it around the bobbin. This is the elegant solution to what had been for thousands of years, from the very beginning, the dawn of spinning, a two-step consecutive process. With the invention of the flyer, both the twisting of the fibers and the storing of the thread are done simultaneously. It truly is a remarkable invention. Now, let's say that you have purchased an antique wheel and the bobbin does not move freely, which often happens. Often there is 200 years of accumulated gunk inside the hollow wooden tube that prevents it from turning freely. So, what to do? What you do is you have to take off the whirl. Now I'm going to put my prop aside for a second. You have to unscrew the whirl, but this is the tricky part, because there is a metal nut embedded in the end of the wooden whirl. The trick to remember is that this nut has a backwards twist on it, or backwards thread. It's opposite from the standard nut and bolt that you would get at a hardware store, for example. With a standard nut and bolt, when you want to screw the nut on, you turn it clockwise, and to unscrew it, you turn it counterclockwise. It's opposite on the whirl, for a very good reason. It's opposite because the drive band itself is going in a clockwise direction. If the threads on the nut themselves were also going clockwise, what would happen is that the whirl would simply unscrew off the shaft and would come loose. So they realized that in order to keep the whirl on the shaft, it had to go in the opposite direction from the spinning direction of the drive band. So what you're going to do is you're going to actually turn the whirl in a clockwise direction to take it off. Many a whirl has been destroyed by stripping the threads on the metal nut by people who simply did not realize that there is a backwards, or as it's also called, a left-handed thread on the nut. Then you can take off the bobbin and you can see the hole that's drilled out along the shaft, the wooden shaft of the bobbin. Then you can take even a small round file is good for sticking through the length of the shaft and cleaning it out. Once you have it cleaned out of the accumulated gunk, it's a good idea to spray some powdered graphite into the shaft, and that way it will help it revolve and spin easier with less friction on the metal spindle. So we're going to put the bobbin back on the spindle. We're going to take the whirl, and again we're going to turn it in the opposite direction from when, or the opposite direction from what you would normally think of in order to turn on the nut. And there you have it. This is a complete flyer mechanism. As the drive band is turning the bobbin in a clockwise direction, since the threads are going backwards on the whirl, the drive band is actually tightening the whirl up and preventing it from loosening and coming off.